So tonight the topic is gRPC, and Antonios Chariton will present. And after that, please stay with us for a virtual networking event. So about DevStaff, let's see. DevStaff is a community. As a goal, we have, to bring people who are passionate about technology and software and together. And our motto and our tagline, if you will, is that it's your community. And by community, we mean that we have no titles, presidents, etc. We also have no elections and representatives. And we are trying to be open as in open source. And of course, as many of you know, in open source, there's a catch. And what's that is active participation. So how you can participate, how does someone participate in the DevStaff community? You can join us on Slack or issue a PR on our GitHub page. And also participate in the organizational team meetups. And about the meetups themselves, they take place at the second Thursday of each month. And you can, of course, attend and suggest topics there or have your say. And you can actually also vote about the subjects that may be of interest to you. So all this is happening through the meetup.com platform, which you get notified for new events. And please also do RSVPs. And you can also send your feedback in there. Like I said before, there's also a GitHub page in which you can always open an issue for something that interests you. And about the voting procedure, it's the org's team responsibility to curate, topics and select the most promising. Then what we do is that we send the link via the meetup.com platform, and you select the top 5 of them, vote, and of course the org team then goes off to find speakers, and that's where we also need your help. Maybe propose a speaker that you know or watch somewhere else, or just could be you. So we also do, at least we did some hands-on events, hack sessions, we call them. So it's all about, participating in learning some fun stuff, let's say, about technology and things. In the past, we have done Docker, Torp, HashiCorp, etc. And you can always open an issue on GitHub or propose it on Slack if you don't want to, organize something like that. And we're happy to facilitate organizing it. Another important aspect of the community is the jobs board. So what we do is, what we have is like a job board at GitHub, in which you can find many job openings and companies of Crete, but not only Crete, are posting the jobs there. So if you are looking for a job, that is the place to look. And as a community, we have a code of conduct. A synopsis of it is like, let's just be nicer, let's just be civil. And this is the time that I will ask the audience if anyone has announcements to make, something important maybe.
Εγώ έχω μια ανακοίνωση.
Okay.
Okay. Hello, I am Michael. I have an announcement, but I will say it in Greek because it's only about Greeks, since it will be in Greek. Sorry about that. Οπότε μιλάω εκ μέρους του BizRapt αυτή τη στιγμή, του οργανισμού. Την επόμενη Τρίτη, 13 Οκτωβρίου, πραγματοποιούμε ένα webinar σε συνεργασία με τη Ζαχαρένια Τζιτζικάκη με θέμα οδηγός επιβίωσης remote management. Είναι ένα 2ωρο webinar που θα σκιαγραφηθεί διεξοδικά η διαχείριση απομακρυσμένων ομάδων και απευθύνεται σε νέους ή έμπειρους managers remote ομάδων, αλλά και στελέχη HR. Εάν επίσης σκέφτεστε το επόμενο βήμα της καριέρας σας να είναι manager είναι επίσης για σας. Για όσους δεν γνωρίζουν τη Ζαχαρένια, να αναφέρω ότι είναι VP of Design του Workable και την εμπιστευόμαστε σαν ομάδα γενικά τις γνώσεις της και την εμπειρία πάνω στο θέμα. Το webinar είναι με αμοιβή, ωστόσο το κόστος συμμετοχής λόγω του BizWrapped είναι με πολύ μεγάλη έκπτωση. Επίσης, οι θέσεις είναι πολύ περιορισμένες για να έχουμε καλύτερη ποιότητα. Αν θέλετε να μάθετε περισσότερα, ή μιλήστε μου ή πηγαίνετε στο bizwrapped.gr, στο τελευταίο μας blog post, έχουμε αναλυτικά τι χρειάζεται. Αυτά. Ευχαριστώ πολύ.
Τέλεια. Ευχαριστούμε πολύ, Μιχάλη. Κάποια άλλη ανακοίνωση?
Ήταν ο Μιχάλης ο Βελονάκης, για όσους δεν τον ξέρουν από τη φωνή τον αναγνωρίσω.
Ναι, θα μπορούσα και εγώ να κάνω μια ανακοίνωση.
Εννοείται.
Είμαι ο Σταύρος Μπαστάκης. Στην εταιρεία που είμαι, στην Φέρλο, αναζητούμε 2 θέσεις. Μία για backend και μία για full stack. Τις έχω ήδη ποστάρει στο chat. Μπορώ να τις κάνω reshare για κάποιον μπορεί να ενδιαφέρεται. Και ό,τι θέλετε μου στέλνετε και σε private.
Σταύρο, να υποθέσω ότι θα σηκωθούν οι ίδιες αγγελίες και στο Jobs.
Ναι, σωστά. Θα ανακοινωθούν και στο Jobs, στο Slack, αλλά και στο GitHub του DevStaff.
Okay.
Τέλεια. Άλλη ανακοίνωση? Κάποιος άλλος? Οκ. Νομίζω είμαστε έτοιμοι να ξεκινήσουμε. Οπότε... ναι. Αντώνη, έχεις το λόγο.
Thank you. So I will do something that I've never done before with DevStaff, which is this. Hello, everyone. It's been a popular request to finally turn on my camera. Okay, now you should be able to see the presentation, right?
Yeah, go ahead.
Sure.
Okay, great. So this presentation, the title, as you may already know, is gRPC Forget About the Rest. And as you probably guessed, we're going to be talking about 3 things here. We're going to start with protocol buffers. Then we will get into gRPC, the main topic of this event. And finally, we will talk about REST, which can be seen somehow as a competitor to this scheme that we will be proposing, that I will be showing today. So for now, let's just forget about the rest, and we will focus on protocol buffers and gRPC. And we will start with protocol buffers. There are many programming languages that we all use, different ones every time. And within a company, more than one may be used. And in each programming language, there is a way to group variables together. And it's called a struct or a class in some other languages. And it is a message that we can then send to another application so we can communicate across the network or using some other medium. The problem is that every language, every programming language has a different representation of this data in memory. So although we have some integers and some floats, for example, each language represents them differently in RAM. So if we want to communicate with other services that are written in different programming languages, we have to somehow find a way to be able to encode this data, convert this struct to a common format that's understood by both ends, both languages, both applications, and be able to do this. The most popular one probably is JSON. JSON is a message format, it represents these structs and these classes possibly as a string, as a piece of text. So another format is XML, and protocol buffers are just another format that encodes data and is common across programming languages. So if we now want to send something from an application written in Go to an application written in Java, we just encode this payload, encode this message into JSON or XML, and then we just send it to the other service. So the other service can then decode this, do the opposite, and then have it accessible as a native field. So you can do customer.name and retrieve the name of this object. However, now we designed the application and it's working and everything is great. However, in the future, we may need to add more fields to this payload, to this JSON message. So if I'm developing an application and I say, hey, we need balance now to be included in the customer object, and I write Go, I will go to the definition of this struct in my file, in my code, and I will add the new field. And then every time I send this data, it will include the new value in it. However, the other side of it, the other application doesn't know about this thing. So it has to, the developer has to somehow know that there is a new field called balance and go into their piece of code and try and add this field there as well, so they can now receive and read or write this to this new field. And what usually happens in this case is we use documentation. So the person that creates this API, this REST endpoint, has to document everything. They have to describe that this is the output format that I'm using, and it contains these fields. And then every consumer of this, every person that wants to talk to this service, has to follow up on updates on this documentation. And if there is a new field, they just have to go to their code and add this field to their code. And the two ends may not be the same person. It may be a different person, a different team, a different company. So you need to communicate all this across companies or have it somewhere commonly visible and accessible. And another problem that you may have with APIs is that as you add more data, you come up with new versions. So you need to have a way to somehow version this entire thing. And at some point, you may even have to make breaking changes. So instead of a float, you now need to use an int for this field. So they're not backwards compatible. You cannot use the data structure that you had before with the new data structure, which is a problem because it also means that you need a new endpoint. So there is a transitional period after you update your application where you update it, but then you have to give some time to other people to also update their code. And at this transitional period, both applications need to run at the same time. And the problem here is that if there is a breaking change, you can't have it under the same namespace. You have to name it something else. So you end up with an application that has a root for V1 and another for V2, and it can create some messy code there that's not so clean because you may have even some repetition between the two. And on top of that, another problem that exists with JSON is that we have this field, that's a JSON message here that we are using. And in order to generate this message, the code that is creating this, the Go code in this example, has to define a struct that has these fields. And the code reading this, the Java application, has to define a class with these fields, so it can decode this message into this class, which means that we send all this information here, but the two ends, the person that creates the service that creates it and the one that decodes it, already knows all these things. So both ends of the communication know about the field names, the object name, they know about all of this. The only thing they need to know is the variables in red, yet we still, every time we want to store this or send it, every time we just send this information again, although nobody needs this. So that's a bit inefficient. If you're using a JSON for storage or for sending messages over the network, this can quickly add up. Having information that's not required can quickly add up in either storage costs or bandwidth or anything else. So the problems that we saw, and possibly a few more, can be solved by protocol buffers. Protocol buffers is a technology that was created by Google, and it's an encoding scheme that allows, basically it's similar to JSON or XML. The only difference is that in the binary encoding, the final bytes that you get after you apply this encoding are as tightly packed and as efficient as possible. So the field information is not included. It's designed specifically to only include the information that you need to know. It doesn't have anything else in there. So it attempts to be as efficient as possible on the wire or as a storage thing. And to have a look about how you define a protocol buffer, basically you create proto files with the .proto extension, and then you have to just define everything in there. In this case, we start with the syntax. There are various protocol buffer versions. So there is 1, 2, 3, and maybe there will be a 4 in the future. So you have to tell you have to define in this file which version is being used. And then you just define this structure, this struct or class in the programming language. You just define it that here it's called the message. So here we have the same customer message as before. We have the variables here and their type, and you just define the type. And you may also notice that we have some numbers in the end of the file. So what are these numbers? In a programming language, typically when you say name equals something, you assign this as a value. Here it means something different. Here it is the order of the fields. So you know that the first field you're receiving in this binary message is the ID, the second is the name, etc. And you may wonder, why do you need to have the order of the fields? Where as the application grows, you may need to add another field later on. So you may have a new field which is called email, and you need to have them ordered somehow. But now, as you have this application and it works just fine, privacy laws may change, and people may come and say, well, you can't store the age anymore in your database. You have to delete this. For this reason, protocol buffers support keywords support tags, sorry, on the individual fields, and one of these tags is deprecated. So we can say that the age field existed before, but it is now deprecated. It's no longer used. It doesn't mean anything from now on. Now, as you may notice, we couldn't just go ahead and delete this field, because then they would come at a different order. And in gRPC, we don't have we don't send the key every time for efficiency. We only send the value. So we need to maintain this order and the type of variable, like float, for example, of this order. And now let's stop for a minute and compare this to some documentation for maybe a JSON message that may have multiple versions. We started with the first 4 fields, then we added another one, and then we deleted essentially the third field, age. Just by looking at this message, this protocol buffer message, I can understand everything that I need to know. I can see that there is an email field right now, and there is a balance field, and there is everything, and there used to be an age field, but it's no longer used, so I shouldn't really worry about this. So you can immediately tell everything, and you don't really need all the history before that. If you want to implement this service, if you want to write a client for this, you have everything that you need. Of course, other things that are supported in protocol buffers are arrays, lists of things. So for example, you do this by adding the repeated keyword before the list, so you can have a repeated float balance if you for some reason need to have a list of objects. And another thing that exists is the required keyword. There is the required and the optional keyword. So you can say that this message must have the ID field set, and or this field is optional. You can define this so you don't have to later check it with your code that this field is indeed there. And there are some problems with the required and optional fields, so they're no longer recommended. Mainly, it is how do you deprecate a required field. It's a bit difficult, like because clients that have not updated to see the deprecation, they will still require it, but clients that have this field deprecated, they can do this. And also, how do you change a required field to an optional or the opposite thing? So these keywords are no longer used, basically. They are no longer required. And of course, since protocol buffers, this is a programming language, a definition language, you can import other files. So you can have the definition in a different file. Like here, I used a variable of type address, which is another message, and I can define this in another file. I can import all the files that I need separately and split them into multiple files depending on what I need. Another keyword, another option, another feature of protocol buffers is the one-off field. You may have 2 fields that are mutually exclusive, or 2 or more fields that are exclusive, so you can't have them at the same time. For example, if you bill someone, you can't have receipt information and invoice at the same order. It may be a bad example here, but it essentially only allows you to set one field. So in this case, you can't have both fields. It's not required to use this, it's just convenient. So you may have some data models that you have and can use one of these features. They are available to you. And of course, protocol buffers support enumerations, so you can have a countries, that's a variable type, and then you can set it to gr or ch or whatever else you want, and you don't have to remember these numbers. So for example, if you have some log file that is in protocol buffers, you can have the log ID, the type of this log. If it's an information or a warning or an error, you can just have an enumeration there, and it's a native field. You just set this variable to gr, and that's it. So you write all these files, you have all this code, you define all the messages that you want to have in order to send to other services or to store to your disk. What do you do then? There is a program, a binary, which is called proto-C. This is the protocol buffer compiler, and it does one thing, and this thing is to take proto files. It takes some definition that you wrote in this language, And if you import other files, of course, it takes these files as an input as well. And then it will automatically generate all the code that you need for the programming language of your choice. So it will generate all the Go files or the Java files, anything that you need. Basically, then you will have a library or a package in some other language, which will have a native data type. So all these messages that we defined will be available as structs or classes within these programming language, and they will have the setters and the getters automatically created. So you can set the variables or read their value using these methods, these functions. And of course, you get functions to take this struct and encode it as a binary to get the final format of it and store it or send it over the network. And you can, of course, have a function to do the opposite, take the binary format and then convert it into a structure that your language understands, that is native to your language. And all this is done automatically. And every time you change this proto file, you have it somewhere on Git, for example, and you push a change, every time a new field is added or something is deprecated, you just have to run the compiler again, and your library is updated. You get a new version. You don't have to go and manually find fields and change them and add them. And the code will be generated for every programming language that you're using. So you do this once, and you have your Go library and your C++ library. You have any library that you may need, and you use protocol buffers for. Protocol buffers are available in many languages. Here are some popular ones that you can use today. Of course, more languages are added constantly. So even if you can't see your language, it may soon be coming. And yeah, I was talking about good programming languages. Anyway, so gRPC, that's the second part of this talk. It's mainly the topic for tonight. And we have protocol buffers, which allow for a very efficient encoding that JSON or XML cannot provide. And now let's see about gRPC, which is a use case for them. You can just use protocol buffers on their own. You don't have to use gRPC with them, but that's probably the most common use case right now. So what is gRPC? Do you remember this field that we had before, this JSON message that we had earlier and that we wanted to send to another service? Well, if you remember what we said, most of this field is useless anyway. So it transmits information that both ends of the communication already have and know. They need to have this in order to communicate. So you already lose some efficiency if you go with JSON, where it turns out that if you use REST, a REST API with HTTP, this is not just the message that you transmit. You don't just send a JSON file, you send much more every time that you need to do something. So you send the method type, a put request, the endpoint, the HTTP version. You send the user agent, the content type, which is always JSON, for example, in an API. You need to send encoding information, compression information. You need to send the host that you address this to. You need to send a lot of information on top of the already inefficient JSON message. And then you are even less efficient if you use JSON over HTTP. Another problem that you have is that by default there is no authentication or authorization in the protocol, so you have to implement this on your own. And in the previous century we used IP addresses to do this. So you blocked IP addresses and you allowed some others. And now we use more modern systems with tokens and secrets and even asymmetric encryption. We have many systems to make sure that not every service or not everyone on the internet can talk to this thing, and only authorized people or entities in general can talk to this. And since it's not supported, you have to implement this on your own. You can sure find a framework or a solution that you have to get and just use it on top of your application, but it's not supported natively. And of course, all these secrets and these tokens, by default, you send them over plain text HTTP. So all these secrets, you just send them unencrypted. And it may defeat the point, but a lot of people just may say that, okay, my internal network or my microservices network is encrypted and everything because it's a problem, but I let the network guys handle it. I don't care about it as a developer. The problem is that's often not the case. So ideally, you may want to consider authorization on a per service level and not rely on just the security of the network that maybe another team or company provides to you. So that's this sounds like another problem that that may exist by default on HTTP and REST endpoints. But sure, you can have HTTPS and you can have other things on top, but this is an insecure default, which is not something that you want to have in your code and services. Another problem that we have, and the chat was faster on this one from what I've seen, is about live data. So imagine you have something that is time critical, like you have a multiplayer game and you want to sync state, you want to exchange messages between all the players very, very fast. One way to do it with HTTP is polling. So every 1 second you send an HTTP request and say, do you have any new data? Do you have any new data? And you just keep asking this until the game ends. Now, if new data is available every minute, you just waste a lot of resources. If new data is available every like 100 times a second, then you are too late to learn about this change. So polling doesn't work. You have to use another technology like WebSockets. But if you use WebSockets, that's a completely different system. So you have to implement everything there again, like your authorization scheme and all these things. They have to be re-implemented in WebSockets, and you have to get used to a new logic that the WebSockets come with. It's not it's not this stateless REST thing anymore. It's this plus something else for another use case. And do you remember this documentation that we had about our API before? If we also need to include all the endpoints, all our service endpoints, you end up with much more documentation. So you just have more things there that you need to maintain. And it's not always very easy. So you may have like some older API that you still need to maintain for 6 months until you shut it down. Are you sure you're updating the documentation equally well with the brand new thing that you are creating? And also, because documentation in some cases is created by humans, because in HTTP and REST, nobody tells you how to do it. You just have to figure out a way to document this. It may be incorrect. I happened to see a popular API last month that said it returns an integer. And I just created this struct by hand, and it was always 0. It turns out it was returning a string instead. So you don't have this in sync necessarily. You don't always have this this tight coupling between the documentation and the code and what's actually happening from this service. So much like protocol buffers, gRPC tries to solve these problems. And again, some more, but this is just a very short talk. It's only an hour, so we don't have the time to go to everything. We're going to see how gRPC solves these problems, though. But how does it work? So we have these proto files that we defined all our messages before, all the messages that we use to communicate with other entities, other network services. And gRPC essentially allows us to create a function on top of this data, an endpoint for REST terms. And how do you do this? Basically, you create a service, which is called, in this case, customer database. And then you define all the functions that you want this service to have, like an add customer and a get customer. And like programming, every function has an input. For example, add customer takes a customer object, so you have to give it a message of type customer. And it also returns something. In this case, it doesn't return anything. You don't need to have some results from this operation. But in get customer, you can have an actual result. So this is again a bad example, because in order to get a customer, you have to send the customer, but it could be a customer query message that you send. You can define another message, which is called customer query, and can have all the fields that you need to perform this search. Basically, data modeling depends on your use case. So you just define all your functions and what they take and what they return. And what you do afterwards is the same thing as before. You use the same tool that you use with protocol buffers. You use proto-C. So it's the protocol buffers compiler. It is exactly the same as before. You give it the proto files, the input that you want to have, and then it generates all the code, all the server code to implement this service, all the client code to talk to this service, all the native data structures that you need. It will create all the libraries or packages that you may want to have in your program. It does it automatically. And some programming languages may have some special needs, like Java, for example, where you have packages. So when you import something, you have a package name, an ID basically, which is the reverse notation of a domain name. Proto-C will generate one for you, but if you want to define a name for this thing, you can just specify an option. So this is just an example here that all the Java code that's generated is going to have this package. You can have similar flags for C++ or any other language that's supported. And how does it look like? What is being generated? I have an example here with Go, because slides have limited real estate. I don't have unlimited horizontal or vertical space, so I can't use Java as an example. But let's go with Go. So as you can see here, we have the get customer function. Basically, this is the function name that we defined in this protocol, this proto file. It's the same name as there. And this function has an input, which is a customer query. By the way, this PB here is the library that was created by the compiler. So all this code is created automatically. And this customer query is a variable. It is a struct in Go of type customer query. So we take this as an input, and then we return a customer object as the output. And then the only thing that you have to do as a programmer is write the code for this function. So gRPC unfortunately cannot do this for you yet, write the code, but I think it does already too much. You just have to implement the function code that you want. So this get customer, what does it do? In this case, it just returns the same object no matter what. So it's, again, a very terrible example, but it's one line. So that's very good. So what about streaming of data? What's the WebSockets equivalent here? Well, you just add a single word to a single keyword to the input or the output. So in this case, this add customer will receive a stream of objects. So I will keep constantly sending customer objects, and when I'm done, it will just return nothing in this case. You can also have the function return a stream of data. So you can have you can send a subscribe request, like you can say, give me the price of stock X, send a single message, and then the return value will just be a stream of data which will contain the price of this stock. And in gRPC, you can have streaming input and output. If you add the stream keyword in both parts of this function, you have bidirectional communication. So you can keep sending all the messages that you want, and you can also receive messages at the same time. So it creates this bidirectional channel of communication. But we haven't seen the most important thing yet, which of course is security. It's always the most important thing with software development. So we saw that REST by default does not have any authentication or anything like that. In gRPC, basically there are two modes. There is the insecure mode, the HTTP mode, and this is completely insecure. Everything that you send is unencrypted, it's plain text, everyone can read it, and there is no authentication. You may be talking to the real server, you may be not, you will never know. And you can implement something on top of that if you want. Another mode of operation is TLS. So all the communication is end-to-end encrypted. The server has a certificate, it is authenticated, and this is the recommended mode that you have. And optionally, you can also authenticate clients as well. So you need to have, if you need to have something like only accept specific applications from talking to you, you can just only accept specific client certificates. You can also create your own modes. If you're not satisfied with any of this, you can create your own modes, and there are modes out there that are public, and you can just start using them in your project directly. So you have this ability as well, and you can use this for authentication. Now let's quickly go and see a client example. So, okay, that's all the server part. Now I want to use this as a client. Let's say I have a service that already exists, and I want to use this, consume this RPC service, write a client for it. Basically, I need two things. The first is the server, which you of course need, where you talk to, and you also need the protofiles. The definition of this API. So if someone gives you this, you don't need anything else. You don't need no documentation. You don't have any more needs. You just take these things, you generate with the compiler your Go library in this case, and you just use it. As you can see, the first part, we just dial into the service. We connect into this service. So we just send a message. We just open a connection. And if you see this gRPC with insecure, that's a really nice thing of gRPC. If you want it to operate insecurely, you have to tell it that. It's not insecure by default. You have to explicitly say, I don't want any security here. I know what I'm doing. And in this case, we say, I don't want any security on purpose. And of course, you do error handling, you check errors and exceptions. I imagine everyone does this. So that's the next part there. And all this is just generic gRPC. There's no library yet. What you then do is create a client that uses this connection. So you just create a new client, and then you can just make requests with it. You can call methods that are defined in the proto file. I can do a get customer, and I pass a customer query, which is basically the message that this service needs. And then I get back a response, which is a customer object, and I can do response.balance just fine and read the response. And that's it. That's the entire code that you need to interact with this service. And it's native data structures. This customer query and this customer objects, you can access their fields in Go or Java or any other language natively. gRPC has support for many languages, and you may see some things that are not languages here, like Android. For Android specifically, there exists a lightweight version that's specific for Android apps. And there's also Objective-C. So if you have a mobile application, it can talk gRPC with your endpoint. You don't need to use REST. You don't need to use any of that. You can just talk gRPC for all your communication needs. And yeah, that's the programming languages. But you may be wondering, what about REST? We want to talk about this as well. That's part of the presentation. I may have a browser that only speaks REST. Browsers don't speak gRPC yet, so I have to use REST. Or I have some clients that want to talk HTTP and REST with me. I can't just switch to gRPC and just forget about them. There is this thing that there is this let's say decision that you need to make. Do you support gRPC or do you support REST? gRPC is clearly better because everything is documented and the code is generated from the documents, and it's much more efficient because it uses protocol buffers. But you have to use REST in some cases. And do you just create the same thing twice? That would be terrible. Or do you just set for REST in this case? What do you do? Well, luckily there is this thing called gRPC Gateway. That's a plugin of the compiler, and it creates code that translates HTTP and JSON to gRPC. So you have all this code being generated that handles the translation. So what you need to do as a developer is write your proto files, create your gRPC service, and then just compile a REST endpoint with it. You only need to write one version, the gRPC version of your API, and then everything else will be handled by the compiler. You will get a gRPC server and you will get an HTTP and REST server. So you can have both at once. It's no longer a dilemma. Which one do I pick? And as a bonus, gRPC Gateway generates automatically OpenAPI or Swagger documentation based on your proto files, on the services that you have described. And because it's generated from the single source of truth, the proto file, it's always live, up to date, and accurate. And you can give this to all the people that want to talk REST and HTTP with you, and just point them to this documentation. There are some changes that you need to make to your proto files for this to work, but it's very simple. Basically, the thing that you need to do is specify the endpoint. So for example, you may see post here. This means that we need to make a post request to /b1/add customer. So you just have to specify under which name this service is served as. You don't need to do this for gRPC, but since you need to have this route, this endpoint in JSON and in HTTP, you just have to include this. And now there are two main methods that you can deploy this in production. The first is using the Envoy proxy. This is called gRPC web in the documentation of gRPC. So Envoy proxy is a ready-made software like Nginx that is cloud native. So you either deploy your gRPC service and it is running in a server, a VM, a container, whatever. And then you also deploy an Envoy proxy. And gRPC clients talk to the gRPC service directly. And HTTP clients, they talk to the Envoy proxy, which then translates to gRPC and handles this translation between them. But if this is not good enough for you, there is a way to create something better. And you can create a single binary that listens on a single port. It listens on port 80. And if you speak gRPC to it, it will respond in gRPC. And if you speak HTTP to it, like normal REST, then you get a response back in REST. So how is this done? This is a blog, by the way, a blog post on gRPC by Brandon Phillips from CoreOS. This was in 2016. So it's a fairly old proof of concept that was there. You basically use the same protofile to describe your service. You generate two things, the gRPC and the HTTP server, and then you add a single binary. It checks the content type. If it's gRPC, it uses the gRPC handler. If it's HTTP, it uses the HTTP handler, the something else. Non-gRPC traffic basically uses the other handler. So you create a binary that listens on a single port, and you can speak to it whatever is comfortable to you, and it will respond in your native language. And by having something like this, you can really forget about the rest, because gRPC just has the best of both worlds. You write your code once, it is documented in the protofile, all the code is generated for you, and you can serve clients that speak gRPC, and that's great, and it's secure and efficient. And you can also serve other clients that don't speak gRPC, and it just works, and it's fine. And here I have some links and resources for you, and pretty much that's about it. So thank you.
Thank you, Adoni. Questions, guys? Anyone would like to ask something? Just raise a hand and unmute and start. Let's see if you have any questions.
To be honest, I have tons of questions. Most of them are provocative, but yes, let us try. Yes, this is Kostas. So, Antonis, it was an excellent presentation, first of all, and thank you very much for the effort. My first question, when I first saw this gRPC thing, is what about C, plain old C? Why don't they support C?
Great question. Well, you can use C++. And...
Yes, but this brings me actually to the real question, is that this proto-C is actually controlled by your favorite employer. So if your favorite employer doesn't want to include a programming language for whatever reason, then it is not included. It's been years since I have seen that. And of course, C is still not supported. And I guess it is on purpose. Correct?
So thank you for your question. Something that,
as I said.
Exactly. And I know why you're here and why you're interested in gRPC. But let's say that something that I forgot to mention, and thank you for bringing this up, gRPC is not Google's, it's actually a project of the Cloud Native Compute Foundation, CNCF. So it is essentially, if you want to find who controls it, I would say that it is CNCF. And I would defer you to them.
Yes, okay.
I would like to defer you to them.
Yes, this is something I will send it in a chat. I will definitely need to go back myself. There are, of course, various other alternatives of binary encryption, of binary, let's say, serialization protocols and stuff like that.
Yes.
I had recently seen an article that just mentions, with a provocative again title, "Proto buffers are wrong." I will send it to the list and I will go read it again, because most of the stuff, to be honest, I didn't, even myself, I didn't understand it. So it's a very good thing to go back and read it after your presentation. So thank you very much once more. Yes.
Thank you for the kind words, and certainly go ahead and read this article. Maybe it had something wrong, maybe it was right, I don't know. I'm looking forward to read it though. Oh, there it is. Great. By the way, I see 57, 60 new messages in the chat, so probably some of them are questions. Anyone want to ask it with voice, or should I go back and read the chat?
Hello, Antonios. Do you hear me?
Yes, I can hear you. Go ahead.
I was wondering, I came a little bit late on the presentation. I saw something about the messages, the protocol buffer messages. They have defined properties such as name, ID, or email. I was wondering, is there a possibility to add the methods to these messages, like some getters or setters, if we could talk about the object-oriented language? Or is it something entirely different from the conceptual objects that we are used to with such languages?
Thank you for the question. Yes, you can add messages into messages and then just do customer.address.city, for example, in this case. So you can just...
Sorry, Antonios, not messages, methods.
Oh, methods. Basically, methods are is handled by gRPC. You cannot do customer.something, I think, but you can have a add customer method on top of that, because it's RPC, so I'm not sure if that would be easy to do.
So the methods are an extension that comes with the gRPC?
Yes, basically protocol buffers define the data structure, the variables, and gRPC adds an endpoint that runs code on top of this message. It processes this message and does something with it, and maybe returns something as well.
So we could say that the protocol buffer is in an LVC pattern is the model and the gRPC is the controller. Would it be right?
I do not know. I think it depends. So I don't know if it could be represented in an MVC pattern. So I'm not. I think it depends.
Okay, thanks for the clarification.
Thank you.
Well, guys, other questions, please? Or if there was something written in the chat, could possibly someone reiterate verbally if there is a question, please? One
question, not by me, but by Arthur, is if you can still JWT.
If you are... Yes.
Maybe I'm going to ask it again. Hello there. My name is Arthur. I have a question. So I've been working with gRPC for, I think, 2 weeks right now, and I'm just wondering, whenever I make a like Android application and I have a microservice running in Go, and I want to talk with this microservice, am I still able to like implement some kind of JVT authentication layer between the microservice and my Android application?
I did not have time to go through this a lot in this presentation, but there exist ready-made schemes already, and you can find a lot of open source work. Some of it is even from Google on for example, error messages like error types and also authentication. So it depends on how you want to use it. Do you want to have it in the do you want to write the code yourself to do it, or are you looking for something that is ready-made and you just start using it? But probably you can use JWT with this. Like it depends on what you define use, because if you re-implement everything in Proto, of course you can use it, but I'm not sure. I would have to look it up.
Thank you very much.
Thank you.
I also have a question.
Yes, hi.
Hi. Okay, we saw the overhead with JSON strings that we sent. I'm not sure that you showed what the overhead would be with Proto.
Yes, correct. Basically, Proto only includes the values, and they are binary encoded. So it is probably the least amount of space that you could have. There are some measurements, like some comparisons between the two, but it was designed back then to pack values as efficiently as possible. So it's probably better. I don't have the numbers in the presentation, though.
Okay, thank you.
Hi, Antonios. I'd like to raise a question. I'm Ioannis, by the way. You mentioned about protocol buffers that they support deprecation of APIs, of fields of an API. But it's a very common thing to see incompatibilities between server and clients. So I was wondering if protocol buffers or it's gRPC that is providing some solution to having disconnected parts in this communication, or even having different clients supporting different versions of the API. Who might be handling this?
Okay. Well, thank you. Basically, the fact that both the service and the server and the client have some common understanding is ensured by gRPC, because both the server code and the client code is generated from the same source of truth, the proto file. You can ensure that at least at some point they were in sync. Now, one of them may have never been updated, and the other may have been updated later on. So you may lose sync after some point, but the way the protocol buffers are structured, you may not be able to understand something. Like if you don't have the balance field, you can't hear about the balance, but everything that you did before still works. So because it's in the proto file itself. Now, if the new service deprecated the field that you were using and you're no longer setting this field, you will have problems, like you're not going to get a value there. But this is, it doesn't obviously handle automatically out of sync things. It can't solve this problem completely. It requires some effort from you, but it certainly helps with a lot of cases, let's say. It doesn't fully address the problem, though.
So just to clarify, there is no out-of-the-box support for backward incompatibility changes, for backwards incompatible changes.
Do you have an example of what would be like? Is it a breaking change that?
Yeah, like updating the type of an attribute.
Okay, so it provides you the tools, so you don't have to make breaking changes, but it obviously cannot protect you from doing it yourself. If you really try, you can, or if you just try, you can do this. It just provides you the tools to avoid this maybe as much as possible.
Great, thank you.
Antonios, I have two questions.
As many as you want.
The first one is that I remember at some point that I had seen an announcement of gRPC web for the JS libs.
Yes.
This is not officially supported by gRPC and stuff like that, or it's not supported by the browsers at this point?
Okay, so that's a good question. Yes, there were some plans, if I remember correctly, to add support to gRPC in the browser, but currently it is not supported. And as a matter of fact, last week, Cloudflare, which is a popular CDN and service provider, they added support for this translation from HTTP to gRPC. So, and other clouds, like, for example, off the top of my mind, Google Cloud also supports this as an ability, but it's not in the browsers yet. So you have to do it server side for now.
Okay, and the second one is that you talked about the gRPC gateway and the Envoy proxy. Do you know if there is a fully one-to-one mapping, let's say, of operations of gRPC to REST services? Or there is some features on protobufs or gRPC that are not supported from RESTful services and vice versa?
As a REST service, you mean if you can do, the question is to rephrase this, can you do more things with gRPC than you can do with this gRPC gateway?
Exactly, and so this cannot be mapped to RESTful, let's say, documentation.
I haven't seen this in my limited gRPC experience, but the thing that comes to mind right now is streaming from gRPC and how that would be implemented using this gateway. But I haven't seen how this is done or if it works. So the answer is maybe.
Okay, thank you.
Anyone else? Okay, let me read from the chat maybe. The talk was quite provocative. I don't know. Great presentation, of course it was. Okay, not so many questions maybe in the chat. Yeah, so it doesn't seem to have any more questions there.
I think you got the fair share of abuse in the chat from
one from Yorgos.
the known suspects.
Yes, I expected this.
Yeah. I was expecting more arguments actually on the Java part, and I could see you smirking, if you like, during the chat, but nonetheless, the ones that's supposed to bite didn't. Anyhow, there is, I think we should be putting this to a close today, today's meeting, but please stay. We're using another application that's called gather.town. I think Gerasimos will be posting the links any moment on the chat. And it is like a virtual get-together place for further networking. So we have created a couple of rooms. I think Erasmus can you post the links to the chat, please? And people, you can go in and there's a little character in the screen, and you can move it around with your mouse, and you get together or close to people, so you can take part in the conversation that's happening on that point, and then you can move away and figure out what's happening. Apart from that, this is from DevStaff for this month. Adoni, thank you very much for a great presentation. Guys, thank you very much for joining. I think the greatest number that I've seen today was 73 or 74 people that joined in. Really high number. Thank you very much. Take care. Stay safe. I will be stopping recording now, and you can use the Gather Town for further networking. Thank you very much, guys. See you later.
See you.
Thank you. Thank you. Bye.
Thank you very much.